Hi everyone.
Hello.
Okay, I think today is raining, so that's why your classmate come a little bit late. Uh, okay, so today is Friday, April 21st, and you have homework 9 about section 5.2 and 5.2 are due tonight. And on Monday, you have homework 10 about 5.4 and 5.5. And so your quiz sets, everybody look at me, your quiz sets cover 5.2, 5.3, and 5.4. So your quiz sets won't cover 5.5. Okay? So if you haven't finished your homework on Monday, it's okay that you submit on Tuesday or Wednesday. But the quiz is about 5.4. You better finish 5.4 on Monday so you can be prepared to take the quiz. Is that clear, everybody? All right. And then our exam is on next Friday. Okay. We only have 2 weeks left. It's kind of rushed. I know we have no choice because we need to finish all the course objectives. Okay, so you're prepared to yeah, finish this course. Okay, and then our final exam, yeah, it is on Monday. You don't have much time to study. Okay, so that's why today we will talk about some problems on 5.5. We are still a little bit behind schedule. So on Monday we will like continue with 5.5 and make a little. I give you this exam 3 formula sheet, right? On Friday, we'll also go over it together. And then I posted the review session recording. So over this weekend, we almost finished everything except session 5.5. So you can start the practice exam early, okay? So, and this is the review session. My recommendation is do the practice exam using pencil. After you finish, click the video section. Then you can go over the solution with me, okay? And then after you finish, estimate your scores. If on some problem you get low scores, then change the number to make it another problem to practice. Okay, everybody? And next week, come to my office to ask me questions or email me. Is that clear, everybody? Yes. So the video session recording is right there. So you can pause at every step to think through the math. Okay? And you can watch it at any time. So could you promise me you watch it earlier? Don't waste the night before the exam. Okay, everybody? Try your best to get a good grade. Remember? Yes, you want to do well on exam 3 and the final. So your final can replace the lowest midterm score. I hope your exam 1 is the lowest. Yes.
What happens if your final exam is your lowest? Does that one get dropped?
Then no, it won't get dropped.
Wait, can you repeat what you said like 10 times?
So if your final exam score is the lowest, is lower than all your midterm exam score, then it won't be replaced.
No, about exam 1 being dropped.
No, only if your final exam score is higher than that.
So then does it count all 4 of the exams?
Yes, they count all the 4 exams. So final exam cannot be replaced because they cover chapter 6, and we don't have any midterm that cover chapter 6. Mm-hmm. Okay.
Wait,
Okay, so
no, can you go back to the calendar?
Calendar? Okay, sure.
You said it was cumulative?
Yeah, it means everything.
Yeah, and chapter 6.
And chapter 6. Exactly. That's why final exam cover chapter 6. None of your midterms cover chapter 6. So final exam cannot be replaced by the midterm. So we're not dropping one out of the 4. We're only use final exam to replace the midterm if you have the final exam score is higher than your lowest midterm exam score. Yeah, you need to study really hard. Okay, the remaining 2 weeks. Okay. So last time we talked about how to solve equation involving exponential and logarithmic expressions. Do you still remember this example? So when we see equation involving more than one log, you first condense into a single log, right? Combine in a single log, and when you see plus, you combine into product. When you see subtraction, you combine into division. Yes. Okay. And then after you make sure both sides you have a single log, then you can get rid of the log, right? You isolate the log term. And then to get rid of it, you apply 10 to, because this is base 10, so you apply 10 to the power on both sides. And therefore, you get a quadratic equation, right? And then you distribute, and then you can move all the terms to the left-hand side. You either factor or use quadratic formula. Do you all remember the quadratic formula? So even though I give you like this formula sheet for exam 3, but you not only need to memorize this sheet, you also need to memorize the sheet I give you in exam 1 and 2. Okay, everybody? So, right. And then after you get the answer, because for log, the domain is positive numbers. So you need to check for all the expressions. So you plug in 3, you realize, oh, this is 5, this is 2, so it's okay, right? But when you plug in negative 4, oh, this is negative 2, no, and this is negative 5, not okay. This is outside of the domain, therefore we cannot count this one. Okay, everybody? So we did this problem last time. And we don't have time to do this problem, but the solution is kind of similar. You see this is a plus, you combine the sum into a product inside the log, right? And then, oh, this is also base 10. So both sides raised to the 10 power. And then you see here, we get 5x, x minus 1 is 10 squared is 100. Okay, and then we get common factor 5, both sides divided by 5. And then, oh, this is a quadratic equation. We want to distribute and move all the terms to the left, and then we can factor. After we get the solution, you also need to check whether they are in the domain. If you get something inside the log is negative, that means it cannot be the solution. Okay, everybody? Questions?
Is the solution like all these solutions on the course website? So if
yeah, this is on the course website.
By itself, you can look at the
yes, exactly.
Okay.
Yes, exactly. So here I just want to talk about if this is a subtraction. If this is subtraction, then what do? This becomes log 5x over x minus 1, right? Equals 2. Therefore, if you raise to the power of 10, then you get this cancel, you get 5x over x minus 1 is 100.
So right? Why do we raise to the power of 10?
Oh, because to get rid of the log, you need exponential function.
Okay.
And if you don't see the base, it means the base is 2.
Okay.
If you see ln, the base is e.
Okay.
Yeah. And then here you can solve for x, right? You can both sides multiply by x minus 1. Everybody, do you see that? Your quiz, yeah, you have a quiz problem like this. So you get 100 times x minus 1, and then you can both sides divided by 5. So you get this, right? Both sides divided by 5. And you have x equals, distribute 20x minus 20. And then how do you solve for x? Move the x here and add 20 on both sides. You get 20 equals, what's 20x minus x? 19x. So x is 20 over 19. Okay? And then you plug in here. See? 5x. 5 positive. So it's okay. So you check log 5 times 20 over 19. This is okay. But log 20 over 19 minus 1, is this okay?
No. Negative.
Is it negative or positive?
Oh, it's positive.
Yeah. So this is 1 over 19. Yeah, so 1 over 19 is positive, so it's okay. So this is the solution. So for those of you coming late, please take a picture. Okay? Because in the recording, I write on the board, it's not in the recording. Yes.
I see how you divided by
On
there,
both sides.
so that equals 20.
Yes.
But you didn't do anything with the x minus 1.
Because it's a product. It's a product. You divide both sides by 5, and then if you have product, you only divide one factor by 5. You don't divide both factors by 5. If you have a sum or subtraction, you need to divide both terms by 5. But if you have a product, this is one term. One term you only divide it by 5 one time. If you divide it by 5 two times, you're divided by 25. You're not divided by 5. Yes. Okay. So the black, okay, marker is what happens when you have a subtraction. So this example, you see both, okay? You see what happens if you have addition and what happens when you have subtraction. And when you have subtraction, do you see here you will get a linear equation? You get one root. But if you have addition, you get a quadratic equation. You have two roots. Is that clear, everybody? Mm-hmm. All right. Okay, so that is example 7. Example 8. Okay, let's do it together. All right, you invest $500 at annual interest rates of 6.75%, compounded continuously. How long will it take your money to double? Okay, so compound interest formula. So what is that? Okay, so this is the formulation I gave you, the second page, right? Remember at the bottom, you have the formula A, amount equals principal 1 plus annual interest rate over N times NT. What's A? A is the money in your accounts, right? P is the principal. R is the annual interest rate. N is the number of compounding. T is the time in years. Yes, everybody? Okay. So, and if compound continuously, then we use the formula PE to the RT. This is when we compound continuously.
Interest rate?
R is the interest rate. N is the number of compoundings per year. So if you compound monthly, your N is how many months in the year? 12. If you compound quarterly, 4. Yes, a quarter is 25 cents, but it's it's a dollar divided by 4. Yes. Okay. All right. So right now for this problem, because we compound continuously, we use this formula, right? Everybody? Okay, so $500. That is what? A or the P? The principal, right? Your starting money is 500, and interest rate. So this is R. Point what? 0.675. Right? 6.75% is 0.0675. And how long will it take your money to double? Okay. So our previous problem, we were like, okay, find the amount in your account after 2 years, something like that. Then you plug in the formula. Here, we're asking the other direction. It is asking asking, find the time such that your money to double. Okay, so we want to find the time such that my money is double. Double means what? 2 times 500. Do you agree? Yes, which is 1,000. Yes. So let's plug in. A is 1,000. See, we plug in this formula. A is 1,000 equals P. What is P? 500. E to the R. What is R? Yeah, 0.0675. And then times T. See? We want to solve for T. So this is an equation involving exponential expression. We call, how do we solve equation involving law or exponential expression? You isolate that term, right? Exactly. Isolate that term, which means you only want to see that term by itself on one side. You don't want to see the other numbers, right, everybody? So yes, we isolate it. Okay. So we isolate the exponential term. Divide by 500. What's 1,000 divided by 500? 2. Okay, how do you get rid of E? Yeah, apply ln. So we have ln of 2 is ln of E to the 0.0675 t. ln and E cancel. Is that okay, everybody? ln and E, they are inverse functions, so they can cancel. We get 0.0675 t. Okay, and then we solve.
So we can just add natural law whenever we want?
We don't say add, we say apply.
Well, it's the same thing, isn't it?
No, it's not ln plus 2. It's
Okay.
ln of 2.
You know what I mean?
Oh, okay.
We can just put it in whenever it's.
Yeah, whenever you think it's ready. But you're only ready if the exponential term is isolated. If you put it here, it's not ready. Because it is ln. With the 500 there, you cannot cancel. You can only cancel if it's ln, and then you only have E here. If you have 500 here, you cannot do that. That's why before you apply the ln or the E, you must isolate the exponential term. And like the previous problems, before you apply the exponential function, you must isolate the log term. That's why if you have more than one log term, you need to combine into a single log term first, so that you can isolate it. Is that okay, everybody? Yes, that is really good questions. All right, what is T? ln 2
divided by 0.0675.
Yeah. Okay, put this in your calculator. What do you get? Thank you. 10.26 what? 7? Okay, years. Wow. It takes 10 years to make it double. Okay. So this is problem 8. Any questions about this problem? Okay. All right. So this is session 5.4. Now let's look at 5.5. Exponential. So this is a new handout. Everybody, yeah, new handout here. Okay. So this is the last session in exam 3. Okay. So this weekend, look at your practice exams and do it. And then look at the video session recording to check your work, estimate your scores. Okay. And ask me questions next week. And next Monday, you will have quiz. 6 about session 5.2, 5.3, and 5.4. Okay, yeah, so do your homework and practice exams. All right. Okay, so first, so we're going to talk about exponential and logarithmic models, so applications. The first one is exponential growth and decay. So the formula is y equals k times e to the rt. Okay, so this is the formula. Sometimes we use the notation that, okay, sometimes we use the notation p of t is p of 0 e to the rt. Okay, p stands for population. And P0 is the initial population. Okay, why do we get that? Okay, look at this formula. If we plug in, so initial population, it means that when t equals to 0, the population at 0 is P of 0. Okay, so when you plug in, okay, so when you plug in this formula, you get y is P of 0. And your k is here, e to the r times t. You plug in t is 0. But r times 0 is 0. And do you know what is e to the 0? So this is like e to the 0, and it's 1, right? Anything to the 0 is 1. Therefore, we get the k is p of 0. That's why we get this formula. Okay? So population function equals the initial population, p of 0, times e to the rt. Is that clear, everybody?
So why put P of T again?
P of t is the population of time. Yes. As time changes, your population changes. Okay. When do we use this formula? If your problem were giving you initial population, then you use this formula. But if your problem does not give you initial population, it might give you the population when the time is 2 years, then you use this formula. Okay? That's why, yeah, your second page of the formula sheet, I gave you that formula. Okay, so, all right. And you can see, actually, this formula is very similar to the compound interest, right? The compound interest, A is P times e to the RT. And then here, P of T is P of 0 times e to the RT. So the formula is very similar. K is P of 0. Yeah. So we just have like K is P of 0. And why? How do we get this formula? It involves differential equations, which we won't learn. Yes. Okay. So yeah, differential equation is you after you get through algebra, college algebra, so we are college algebra, and then you go to trigonometry, and then you go to calculus 1, calculus 2, and then you go to differential equations. Then we will talk about why we get this formula. Okay? All right. So now we just assume that we know this formula. Let's do the following examples. Example 1. In a research experiment, populations of fruit flies is increasing according to the law of exponential growth, which is this formula. After 2 days, there are 10 flies, and after 4 days, there are 300 flies. How many flies will be there after 5 days? Okay, look at this problem. Do you see after 2 days, after 4 days, we don't have initial population. That's why we cannot use this one. Use this one. Okay, so we get all right. So we get y equals. All right. So if you don't like y, you can call it p. So really up to you. Okay. So but if you call y, that's also fine. So this is a formula, and then let's see. Look at the sentence. After 2 days. So when you plug in t equals 2, your y is 100. Do you agree, everybody? After 2 days, y is 100. So we plug in. We get what? 100 is y, k is k, e to the r times t. What is t? 2. Yes. So we get one equation. And then the next sentence, after 4 days, there are 300. So y is 300. K is k, we don't know k yet. R is r. And t, what's t? 4. Do you see in this formula, y and t are variables? K and r, they are constants. Right, everybody? So we need to figure out those two constants are k and r. These two information give us two equations to solve two unknowns. Yes, everybody? Okay. How do we solve two unknowns? Okay, we can eliminate the k. Do you see if we use equation 1 divided by equation 2 or equation 2 divided by equation 1, we can cancel the k? Which way is easier? Equation 1 over 2 or equation 2 over 1? Yes, we divide it. Yeah, equation 2 over equation 1. Then we have integer. We don't have fractions. Right, everybody? Mm-hmm. Equation 2 over equation 1. On the left-hand side, you get what? 300 over 100 is 3. On the right-hand side, do you see? Okay, let's do it slowly. Do you see the k cancel? And remember, if you have something over something, yeah, we subtract the exponent. R times 4 minus R times 2. What's that? E to the, what's 4R minus 2R? Yeah, R times 2. Oh, I get 3 equals E to the R times 2. Right, everybody? How do you solve for R? Yeah, ln on both sides. And because the exponential term is already isolated. That's why we can do that. Yes, everybody? So we take the ln on both sides. ln and e cancel. We get r times 2 is ln of 3. What is r? Yeah, ln of 3 over 2. Very good. So we get the r. But we have two unknowns. We have r and k we need to figure out. So to find the k, we can plug in equation 1 or equation 2. Which one is easier? The 1 is easier. So we plug in equation 1. By the way, when you solve your problems, write down all the words. Okay? So write down all the words and label the equation. Tell me what you are doing. Plug in equation 1. So we get, let's see, we get 100 equals k e to the r times 2. But r is what? ln of 3 over 2, right? And you times 2. What happened? Cancel 2. Oh, this is k e to the ln 3. What happened? Yeah. Oh, we get what? K times 3. What's k? Yes. 3/2. This one? Oh, don't do decimals. Only use your calculator as a very last step. Because if you get a decimal here, your K won't be accurate. And then your answer won't be accurate. Okay? So only use your calculator as a very last step. Yes, good questions. So change your habits. Sometimes I know you really want to figure out what's this, but it's better to leave it like this. This is an exact number. Okay? So this is better than a decimal. If you need it, you can plug in your calculator and you can keep as many places as you want. But it's better to keep this exact number at this step. Okay? Yes. Only use your calculator at the very last step. Then your answer will be more accurate. Okay, good. We find R and K. So our population is, see, look at this formula we can plug in. K is what? 100/3. And then R is what? Yeah, and then times T. Right, everybody? Okay, and then our question is, how many 5s will there be after 5 years? So we plug in, yeah, T is 5. So we put, okay, 100/3, e to the ln 3/2 times 5. Okay, everybody take out your calculator. So type everything in one line. How do you type it? So you put 100 divided by 3 and then times plus the e, and then you will have a parentheses plus ln, then you will have a parentheses plus 3, close the parentheses. Okay, don't forget the parentheses. And then you divide it by 2, and then you multiply by 5. Parentheses. The common mistake is students miss the parentheses, then it will be wrong. Okay, this when you put the E button, this parenthesis will be given. Okay, and then that's why you have to close this parenthesis. And when you press LN, this parenthesis will be there, so you need to close that parenthesis. Is that clear, everybody? This is how you type in your calculator. So show me, what do you get? 519.6. How about you? 519.6. 519.6. Oh, okay. You know 519.6. Do you know how to do it? Yes. 519.6. Good. And because we're talking about 5s, 5s are integer, right? So we pay 520. So this is the answer. There will be 520 flies. Is that clear, everybody? Yes. Okay, good. This is example 1. Okay. Yeah, this is the answer. Yeah, because you cannot have 0.6 fly. It was cute and flying to 0.6. Okay, so that's example 1. And it kind of makes sense. Do you see the population is increasing? 2 days is 100. For 3 days is 4. 4 days has 300. And so 5 days, 500 is increasing. So it kind of makes sense, right? Okay, we continue. Example 2. A certain radioactive isotope element, radium-226, decays exponentially with half-life 1,599 years. Given a sample with initial quantity 10 grams, what is the amount of the radium-226 after 1,000 years? Yes, exactly. We're decreasing. The rate is decreasing. The population is decreasing. So we have decay. Last problem we have growth. In this one we have decay. Yeah. Okay, so here we get y equals k e to the rt. Oh, let's see here. We have initial quantity, 10 grams. Oh, this is population at 0, is 10. Right, everybody? So actually, in this case, then it's better to use that formula. P of 0 is P. So P of t is P of 0 times e to the rt. Okay, so and then we know that P of 0 is 10. So P of t is 10 e to the rt. Is that okay, everybody? All right. So we still have one constant r that we haven't figured out, right? We know that initial quantity, initial population is 10 grams. P of 0 is 10, but we still need to figure out what is r, right? And what information we haven't used? Half-life. Okay, what's half-life means? So we have the population decay, right? Half-life means this is the time such that the population at that time is half of the original population. Does that make sense? Yeah, we only have half left. You learned that in chemistry class? Yeah? Yes? No? Not yet. What chemistry class?
AP chemistry in high school.
Oh, okay. Will you need chemistry in here for your major? Okay. So maybe you will also learn about this. Okay. Yeah, chemistry. Okay, so half-life. Okay, this is the time. Let's say, okay, let me say, call it T1. It's the time T1 such that the population at T1 is half of the initial population. In this case, it means the population at time 1599 is half of the initial population. What was our initial population? 10. Oh, which means we only have 5 grams left. So after 1,599 years, we only have 5 grams left. So let's plug in. Okay, P of 1599 is 5 grams, so we plug in here. Okay, so the population is 5 grams. On the right hand side, we get 10 e to the r times t. T is 1,599. Is that okay, everybody? Yeah, the population is 5 grams. The time is 1,599. Okay, how do we solve for r? Divide by 10 first. Do we apply ln here yet? No. See, the exponential term is not isolated. Do you see that, everybody? Yeah? It's not isolated. It has the 10 there. So we need to divide it by 10. What's 5 over 10? 1 over 2. Yes. Is e to the r times 1599. Okay, what do you do now? ln, yes, we're ready. The exponential term is isolated. Okay, so we get r times 1599. What is r? One five nine nine. Okay. ln. So ln. L. I do realize sometimes students put the I in. So this is L. Natural log, log, is base 10, ln is base e. Okay, so this is the R. Good. Now we put it back. P of t is 10. E to the R is ln of 1 half over 1599 times t. Now, what is the amount after 1,000 years? So you plug in t is 1,000, right, everybody? So we plug in t is 1,000. So ln of 1 half over 1599 times.
Oh, because after 1,000.
Yes, yes, exactly. Right. Okay. Now I want to everybody plug in your calculator. I want to see if you know how to type this in.
Would it just be simpler to put it in as 0.5 instead of 1/2?
Oh, it's the same. Yeah.
Yeah.
Yes. Yeah, you can do. You cannot. Yes, always happens. Because knowing how to graph the function is our core stuff. So you cannot use the graph calculator. If you are in like higher math class, like stats, then you can work. You have to learn it because the graphing is not the Yeah, everybody type in your calculator. What do you get? $6.48. Do you get?
Yes, the calculator.
Mm-hmm. Oh, parentheses. Yes, parentheses. Divided by that. What's the E? How do you get that E? It's that E. Oh, it's second and shift. That E. So you go back, it's 10 times E. So second and this. Then you get a E. And then, okay. And then you type ln of 1/2, continue. But do you have a scientific calculator at home? This is a graphing calculator. You cannot bring it to the if you know. Okay. So do you have a parentheses in front of that? Okay, yes. Then thank you. Oh, you don't need this parentheses because yes, if you have that parentheses, then yeah, the typical mistake is you start with parentheses, right? But if you put a parentheses here, that 1,000 is not in the exponent. It becomes it becomes down there. So that's why you only put the parentheses after the 1,000. What do you get? Yes. And how are they on the same thing? And colon 2? 6.48. Oh, do you get 6.482 grams? Let's keep 3 decimal places. Okay, so this is the answer of example 2. So far, so good, everybody? So the formula, yes. If you have the initial population, then you can use this one. If you're not given initial population, then you can use that one, okay? And you, yes, we have the 2 unknown, the initial population and the R. Usually the problem will give you some information to help you to find those unknown. Then you plug it back to your formula, and then you can find the population after 1,000 years. So far, so good. everybody? All right. There could be like other problems. For example, go back to example 1. So they ask you to find the population after 5 days. And can also ask you how many days, okay? So I can ask you in the exam, maybe in the exam, I will ask you, okay, find the time such that our population is 2000. I get 2005. How many days you can reach 2005? Okay, in this case, then what do? You want to find the t such that p of t is 2000. Right, everybody? So p of t, this is p of t. You set it equal to 2000 and you solve for t. So you have 100 over 3 e to the ln 3 over 2 times t. You set it equals 2000 and you solve for t. Is that okay, everybody? So this is the other direction. What do? E to the ln 3 over 2 times t. Yes, 2000 multiplied by 3 divided by 100. Because you want to carry out that. So both sides multiplied by 3 and divided by 100. Is that clear, everybody? You want to isolate the exponential term before you apply ln, right? So how do you get rid of that? Both sides multiplied by 3 divided by 100. And do you see the 100 and the 100 cancel? What's 3 times 20? 60. Yes, we get 60. Now we can apply ln. What happened here? ln and e cancel. And so we get ln of 3 over 2 times t is ln of 60. What's t? Yes. Oh, okay. So what's t? ln of 60, ln 3, and times 2. Quick question. Can I multiply the 2 and 60? We cannot. 60 is inside the ln. We won't touch that. Can we divide the 60 in 3? We cannot. They're inside the ln. We cannot do that.
So you put
Just
ln 60 times 2 and divide by 3?
Yes. Yeah, divide by ln 3. Yeah, put that in your calculator. What do you get? How many days? How many days? 3.726. Thank you. 3 days? Us. Thank you. Yeah, that makes more sense. Oh yeah, if the next digit is more than greater or equal to 5, we round up. Yes. So 7.454. Okay. Oops. My word is not working. Okay. Yeah. All right. So yes, this weekend, please do your homework, your practice exams. Okay. So I think yeah, you're ready to do the practice exams because the problem of about exponential models thing like this one. Okay. So, yeah. And Monday we will talk about the log models, and we will have a go over the formula sheet together and ask me questions. Okay, so you watch the review session and ask me questions. Cheers! Let's try our best to get a good grade, and then enjoy the summer. Because you forgot to close the package.
Oh, yeah, okay, thank you.
You're welcome.
Wow.